This is Jenny Kunkel, and in this video we're going to take a look at summary queries using our aggregate functions. Our aggregate functions that they've provided for us are the average, the sum, the min, the max, and the count. And we'll take a look at what the difference between an all and a distinct is when we switch over to SQL Server Management Studio. If I go there, I'm going to be using our human resources.employee department history table to start. If I want to get a count of all of the rows in the table, I can do that using a select count asterisk. This is going to be from the human resources employee department history, and when I execute that, I should see that I have 296 rows in the table. If I decide that I want to get a count of all the department IDs in the human resources.employee department history, what is that really going to do? It's basically going to give me a count of all of the rows that are populated with a department ID. So if I do a count all department ID, I should assume that I'm going to get 296. And why do I say that? If I look at my department ID field, it's not null, meaning that it has to have a value. Therefore, when I do this, I would expect that it's going to return the very same value. Now, if I decide that instead of doing an all, I want to do a distinct, what is that going to do? That's going to return to me all of the distinct values. So if I have 16 different values that are stored in that column, it's going to go through, and every time it finds a unique different value than what it's already counted, then it's going to increment that counter. So I'm going to get a distinct count of how many different departments I'm using within this table. And when I execute that, it's going to be a lot smaller number than that 296. But what about when I do a count on a nullable field? Now, a nullable field is going to have rows that have values and some that do not. And when I try to do a count on a nullable field, it's only going to be counting those rows that actually have a value populated. If it doesn't have a value, if it's null, then it's not going to include that in its count. So if I do a count of my end date, I'm going to see not 296, but only 6. So if I would go through and do a select asterisk from human resources.employee department history, where end date is not null, it should return to me only 6 rows of that query. That should match the count that's being done there. Now, this is a good table, but let's go down to take a look at another table where we can do some of our more calculation-based functions. So this is going to be our work order, production work order table. It has a work order ID, product ID, order quantity, stocked quantity, scrapped quantity, start date, end date, due date, scrap reason ID, and then modification date. If I want to get started, maybe I just want to take a look at how many rows are in that table. I can do that, execute the query, and find out that I have 72,591 rows. Now, I am interested in the total of all orders and what that quantity is. So that's going to be my order quantity. I want to get the total quantity for all orders. I can do that with a sum. It's going to be my order quantity. I'm going to call this total quantity. If I execute that, I can see that I have like 4.5 million something. Now, if I decide that I want to also get the sum of my stacked quantity, and the sum of my scrapped quantity, this total. Then if I execute that, I can see that I have 4,497,000 and I have 10,000 something that were scrapped. So not trivial. But what about maybe I want to find out what is the minimum order quantity on all my orders. So I can do that and do a min on the order quantity. And we can execute that and see that 1 is the minimum order. So there's at least one order that has 1 as the quantity on it. And if we look at the max order quantity, that's going to give us the max. And then we could also then go about doing an average. So that's going to be 39,570. And if we do the average order quantity per order, if we execute that, then it's going to give us 62 as the average quantity per order. If we switch over to Oracle, we have our CO database, and if we want to maybe get the count of all of the order items in the table, we can do that. It's going to be very similar to what we did with SQL Server. I execute this, it's going to give me the count. I can also go ahead and get the count of maybe all products. This is going to be a required field, so it's going to give the same value back, but I could do something with a distinct here as well. And I can see that I have 45 distinct products on all of my order items. If I decide that I want to get a sum of my quantity on all orders, I can do that. I can get the average quantity. I can do the min quantity as well, and the max quantity. There really is no difference in using these aggregate functions. We can see here we have a nice floating point number, and we have our minimum of 1 and the maximum order quantity is 5. So lots of good information that we can get. But what happens if we wanted to get maybe our product ID with our count of products or the quantity for those products? Maybe that's a better solution. If I would go ahead and do something like product ID and then the sum of the quantity from my order items and execute this, notice it's giving me a not a single group function issue. And if I switch back to SQL Server Management Studio and I would essentially want to do maybe the department ID and the count of the business entity ID for each department, it also is going to complain and essentially tell me that the department ID is not contained in an aggregate function and we're not using a group by. So this is kind of the segue to our next video, which is going to be about the group by.